All right, so welcome to Zoom of November 12th. And the first question is number 12 on 8-1. So determine whether the sequence is divergent or convergent. If it's convergent, evaluate the limit. If it diverges to infinity, write INF. Negative infinity, write negative INF. Or if it wobbles, just write DIV. And see, you're saying that the solution you think is off.
Yeah.
Let me take a look at that real quick.
Well, the get help says that it should be 0, but when I put in 0 for the answer, it says it's wrong and it wants
Oh, so
infinity,
that's a different
positive
thing from
infinity.
get help.
Yeah, yeah. The get
So
help.
where do you see that button? Oh, right
The
here, right here.
website
Let me,
submit
let me
answer.
press
Yeah.
that.
So if you click down
Um,
through all the view steps, it's the same problem, just different numbers. And here it
in
says it
this case,
converges to 0.
notice that the fraction here is 4/5 to the n power. Do you see that?
Right.
Okay, whereas now that will converge to 0, whereas in the problem here, it's actually 5/3. It's greater than 1.
Uh,
So it
Are the
seems to be
problems a
correct.
little random? Because my number 12 is different.
Yes, the numbers will be different. These are randomly chosen. So you have a numerator here,
Okay.
5 to the n. Go ahead. You have 5 to the n over 3 to the n. So when you come down here, break up the fraction, it's this 5/3 to the n that's going to grow. Anything greater than 1, when you raise it to a power, as the power gets big, just becomes unbounded. Whereas if the fraction here where it says 5/3 was less than 1, in that get help it was 4/5, then it will actually shrink to 0.
okay.
So in this case, what you see on the screen here, you have a situation where the first term, the 11/18 times 5/3 to the n power, this is going to diverge on you. The second term is actually going to shrink to 0, but that doesn't do you any good because this guy is basically off to infinity. So you would type in INF in this case,
Yeah.
and then,
Yeah,
then
that's what I was missing was the difference between in my case, it was 5/4 versus 4/5.
right, if it's greater than 1 to a power, it's going to shoot up to infinity. If it's less than 1 to a power, it's actually going to shrink to 0.
That makes sense. Thank
All
you.
right, good deal. Anybody else have a question on this one, number 12 on 8-1? Since I've got it up here, are there any other questions that from 8-1 that you're wondering about? Basically, you're dealing with sequences at this stage, not yet series.
I guess it kind of pertains to 8-1 or maybe a lot of them, but it seems like a lot of the problems you could just turn into a definite integral and then plug that into Desmos, and that made it really easy for me to solve. And I'm just wondering if that's going to be allowed on the test or if you want us to like work it out on paper.
No, I think you might get into trouble. Let me see. I'm trying to process what you're doing. First of all, how are you going to integrate this? Well, actually, you can. You can shrink this down, the factorial
Yeah,
one. But when
it's
you
not
start
all
getting
of them.
into something like, yeah, there's like you get logarithms down here. Um,
It definitely wasn't all of them, but a lot of the homework during uh this section, this module, it was just like, oh, you can just plug these into an integral
well, you know what
on Desmos, and then it just
why not
solves
just
it.
plug the function and avoid even the integral step and just plug in the function. In fact, let's do one. I'm going to pull one off here. How about I'll do, since I got this one
Yeah,
highlighted, n
it's
plus 9 factorial over n plus 7 factorial. And
Yeah, I was
I
gonna
don't
say, you
know.
don't even have to integrate it. If you just punch it straight in,
Oh,
Yeah,
you still
yeah.
have to be
yeah,
able to
Yeah.
yep,
interpret it.
and it
But
gives you the graph, and you can very clearly see usually where
exactly.
it's
So I'm going to
going.
go to Desmos. Give me a moment here. And I'll share the screen.
I mean, the trick though, it's going to give you the answer, but you have to know how to read it.
Okay. All right. So, oops. I don't know what that. So I'm going to do y equals, I have n plus 9 factorial over n plus 7 factorial. That's peculiar. Let me try it with x's. Sometimes Desmos is picky.
Well, so
Well,
we
no,
know
that
that that would
actually,
be
that's correct. It'll
yeah,
diverge. Yeah.
divergent. Yeah.
And actually, you can ignore everything to the left of the y-axis. Basically, you can see this thing is shooting off to infinity real fast. Let me pick another one. Let me just go back to the homework real quick. Give me a second here. Let's do this weird one. Cos n over 7 to the n. So let's see what that does. Again, ignore everything to the left. That's nuts. What you're interested in is what's happening to the right. So really what you're interested in what's happening at the integer values. So at 1, at 2, at 3. But you can clearly see that this thing is um, going basically converging to 0. It's flattening out. Does that make sense?
Yeah.
And so this would be a convergent sequence. And you don't need to do any integration on this. You just simply look at the nature of the graph. If it levels off, it's convergent. You have to be careful. Sometimes they don't level off, but it looks like they're leveling off. I'll give you the old classic example, just a simple natural log function. A lot of people will think that's leveling off, right? But it's not. All right, this thing is actually growing ever so slowly forever and ever. So watch out when you get graphs like that. So Desmos graphing can certainly be helpful, and I certainly want you to use it. It's no problem. Just be aware that there are some problems out there that might be a little more subtle than you were expecting.
Okay, cool. That's great to
Yeah.
know. Thank you.
All right. Well, anyway, I did have, let me go back to it. I had a 8-1 up. All right. So this was going to be on the test, or some of these questions will be on the test. Basically, you're just working with sequences at the moment. You'll be dealing with series. That's when you add them up after the test, when you start getting into the next material on 8, chapter 8, module 8. All right. Any last questions on 8? So let me share the screen. So number 8, a trough. This is what my question looks like. So yours might differ slightly.
Yeah, same numbers are
Yeah.
different, but it's the same.
So it's 10 feet long and 1 foot high. The vertical cross section of the trough parallel to the end is shaped like graph y equals x squared between -1 and 1. The trough is full of water. Find the amount of work in foot pounds required to empty the trough by pumping the water over the top. Note the water is 62 pounds per cubic foot. That's a lot. Alrighty. Okay, I'll stop the share. I'm going to go to the other camera. Let me pin that. There's my terrible drawing. You've got 10 feet this way. This is 1 foot this way. My graph was y equals x squared. The idea is to take the slices of take a slice of water, so to speak. I'm sorry, I'll just something like that. It doesn't have it's just representative. So
Right.
what we want to do is we want to set up a formula. So this is basically a slice of water. Okay, so first of all, we need to figure out its dimensions. So we need to figure out the volume. So this is where the graph comes into play. If I look at it face on, it's the graph y equals x squared. And that slice is going to be sitting right about there. So for particular x values, y equals x squared. And thinking if I want to do this, here's the thing, I have to be kind of thinking ahead here. I'm going to be pumping this out vertically. So I'm going to have to come up with a formula that includes how much it gets pumped out. Let me go ahead. So let's just go ahead and play with this. So the volume is going to be 10 feet long by the thickness. Actually, I'll put that last delta x or delta y. All right, that's kind of setting the stage because it looks like I'm going to want to do this as y. So actually, I need to get everything in terms of y. So if y is x squared, what's x?
Square plus minus square root of y.
Right. Now I'll just take the right half and check this out. The width of this slice would be 2 of these guys, 2 rad y. Does that make sense?
Yes.
Okay. That's just the volume. In fact, we can simplify that a little bit. 20 rad y. And now, you know what? We'll just go ahead and write dy because we're going to do this as an integral. I need to multiply it by 2 things. I need to multiply by the density and by gravity. Actually, you know what? No, I don't. If this is already
Well,
yeah, I don't.
yeah, and that one screwed me up too.
Yeah,
Like,
I just realized
I
that.
went right to putting in gravity,
Right. Yeah, that's a good
but you
point.
don't
That
need it.
one catches me by surprise too. So yeah, feet. I'm sorry, pounds is already a force. I always have to remember that. So we have 1240 rad y dy, and that now we have to lift that. So here's again for we have to kind of set up an integral here. We need a distance now, so it's lifted. And now this one, here's what I do. When x is 0, y is 1, right? And when x is 1, y is 0. So I'm trying to come up with a formula that looks like I'm going to do 1 minus y. Let's stop and think about that for a moment. Does that seem right? I mean, it seems right to me. Let me put it all together. When I put this all together, I have 12. I can bring the 1240 out front. I have 1 minus y, and then the rad y dy. And y itself would range from 0 to 1. Okay. Yeah. What do you guys think? I mean, I'm feeling pretty comfortable about this. Do you see how I kind of came up with this? So this slice, wherever it's y units above the x-axis. So it has to be lifted the remainder, which is 1 minus y. Are you okay with that, or let me know?
Yeah. Yeah, I'm
So
seeing
So
that
it.
go ahead.
so the 1 minus y would represent like the height basically of the
Yeah,
water. Yeah.
exactly.
Okay.
So we're basically, yes, we have basically the pounds and the distance. So foot pounds, yeah. And so that's work. Yeah. So yeah, it all makes sense. I'm just kind of convincing myself. I feel this is right. Yeah, the 0, 1 bounds will come from the fact that y is also between 0 and 1. Um, I think we're good to go. Let's go ahead and integrate it. Well, first of all, let's distribute. So it'll be uh, rad y minus, that'll be y to the 3 halves. So it'll be, now we do this, it'll be y to 2/3 y to the 3 halves. This will be 2/5 y to the 5 halves. But because your bounds are 1 and 0, the arithmetic is actually pretty simple. You'll just get 1. So you'll actually get 2/3 minus 2/5. And then zeros will just drop it out. I'll just punch a number out real quick. The fraction is actually 4/15. So 1240 times that. It's 330. Oops, 330 and 2/3. So I'll just write it as a traditional 2/3. That'll be foot pounds. There you go. Does that help?
Yeah.
If you're dealing with metric, you do have to include the 9.8. If you're dealing with non-metric,
Well, what if they gave you I mean, they give you the weight of the water. If they give you the weight of the water in metric, it would still be this. You wouldn't have gravity. That's already taken into account.
yes, but what are the units of that weight? If it's just kilograms, that's not a weight. You have to be careful.
Mm,
Um, kilograms is a mass. That's one of the main differences between metric and non-metric is that pounds is a force, kilograms is not, is that's just simply a mass. For example, I weigh about 200 pounds. Now, if I convert that to kilograms, that's about 95 kilograms. However, if I don't weigh 95 kilograms, I actually weigh, if I multiply by 9.8, I weigh about 930 newtons. So it's a little detail. I think we kind of get lost there. It's just a peculiarity of the two systems. All right, I'll keep this available. Does anybody have any last questions on this? All righty, we'll go ahead
I
and move
guess
on. Yeah, go ahead.
do you have any like acronyms or something to help us memorize that like work formula? It's like work
Well,
times
work is just really force times distance.
force times distance.
That's all it
Okay.
is. And if you really look carefully at this whole monstrosity right here, your distance is the 1 minus y. The force is the 1240 rad y dy, because that's all in pounds. And then this fancy integral, this crazy thing is just really telling you to add a whole bunch of them. So in other words, you could do this laboriously. You could just maybe slice it 100 different ways. You could just work them out separately. But of course, the integral is faster. So in a case like that, yeah, work is just force times distance. Okay. In metric, it's always newtons and meters. And newtons has to be where you take the kilograms and multiply by the 9.8 meters per second squared. In non-metric, it's foot pounds, and that's already a force. Have you guys ever heard the word slug in context of this in physics?
I have not.
A
No.
slug would be the non-metric equivalent of a mass quantity. Basically, to find how many slugs you are, you divide by 32. So if using myself as an example, I'm roughly 200 pounds. If I divide by 32, I'm about 6.25 slugs. That's how much mass I am in the non-metric realm. We don't use that term commonly, but it is the analog in non-metric to what kilograms is in metric. It's a mass quantity as opposed to a force quantity.
Do you know if there's going to be like any conversions on the test? Should we like
No, every
issue?
question on the exam is something you've seen before in your homework. So unless you had a conversion
Okay,
one in your homework, you don't have to worry about that. You'll be given any information here. For example, you'll be given like the density value for whatever liquid you're dealing with.
cool. Thank you.
Yeah, you don't have to memorize any of that. All right. So I'm going to share the screen. Um, Number two from the mod 6 point review right here. This guy did
Yeah, that's the one.
algebraically determine the behavior. That's kind of weird. It's not algebraic, it's analytically. All right. Let me copy it down. 0 to infinity. 1 over 4 plus x squared dx. All righty. Let me go to my overhead. Well, you know what? Yeah, you do have to memorize this one. So the general form for the 1 over a squared plus x squared dx is x over a, I'm sorry, one that, let me write it again. 1 over a arctan x
Yeah,
over a. That's the general form. So you come over here, and in this case, this would be 2 squared, so a is 2. So you have the antiderivative would be 1 half arctan x over 2. Now, to be super technical, I got to write the upper bound as a limb, so I'll call it b to infinity. Bottom bound is fine. And when I put in the infinity, I'll just put in b. It doesn't matter if I divide by 2, it's still infinity. You get this thing. You get half arctan b over 2 minus half arctan 0. Arctan 0 is everybody, it is
0.
0. Right, so this just crosses out. As b goes to infinity, now I'm going to do something kind of illegal here. I'm just going to write an infinity in there. I'm not supposed to do that. Don't tell anybody, okay? But this is one of those things I think confuses a lot of students. So if you remember what the arctan graph looks like, the tan graph actually looks like this. It has multiple branches, but it has asymptotes at odd pi's over 2. And the arctan is by definition always going to be in quadrant 1, which will be over here, or quadrant 4, which will be back here. And so basically what you're saying is as the arctan goes off to infinity, what is the value trending toward? And it's going to be trending toward pi over 2.
Okay, and it's just because we know that arctan is an inverse.
Right.
Okay,
Yeah, that's actually the tan graph right here. But the
right.
arctan would be where you flip it and kind of turn it like this. And so suddenly this pi halves becomes there, and as you take the graph off to the, let it go to infinity to the right, it's just going to level off at pi over 2. Now you can check this. Go to Desmos, type in this integral. Now you can't type in infinity, but you can certainly type in like 100 or 1,000, and it should give you a number very close to pi over 4. So you analytically determine the exact value is pi over 4. Desmos will give you a decimal approximation. It should be 0.78539 and so forth. So you can use Desmos to check yourself. Any
That's
questions
great
on
to
that?
know. Yeah. Um, okay. And so, like, basically, we want to kind of remember our unit circle and just how it relates to sine and cosine and tangent.
Exactly. You really
Yeah.
don't want to forget your basic trig of
Okay.
features. In fact, something that also I'll mention it. The tangent is actually the slope. If you have a unit circle and you pick a point, so it's got a radius of 1, the cosine of, and there's the angle, the cosine is just actually the length of the adjacent leg. The sine is the length of the opposite leg. And if you stack them, sine over cosine, you actually get this slope. The slope is tangent. Okay, did you know that? I mean, did anybody ever tell you this, that the slope of that line is the tangent of theta?
I mean, I took pre-calculus like 20 years ago, so it's
Okay,
good review.
fair enough.
So, thanks.
I teach a Calc 3 on campus, and I have students that sometimes don't remember this. So maybe they were never told. But think about this. When is the tangent not defined? In other words, when is it straight up or straight down for that matter? It's going to happen at one of the pi halves. It'll happen at pi halves, or if you go an extra pi, it'll happen at negative pi halves. So every time you go around the circle, every time you cross the y-axis, either up top or down below, that's at some negative multiple of pi over 2. And now, of course, when you do the arctan, strictly speaking, as a function, you only take it for the first revolution. Yeah, so I guess, yeah, you should probably have this memorized to help you understand how the tangent graph
Yeah.
behaves, and then therefore how the arctan graph behaves.
Awesome. Thank you.
Sure. All right. So 7.2, number 15, infinity. The base of a certain solid is that. The base of a certain solid is the area bounded above by the graph 16 and below by the graph of 25x squared. Cross sections perpendicular to the y-axis are squares. I see the picture above. Let me bring that up. That just happened. Oh, there we go. I don't know. Can you guys see that? I don't think
We
you
don't
can
see
actually.
it, but
No.
All right, that's
yeah.
right. I can see it just fine. All right, I'll just draw it. All right, no problem. Um, Let me go back to the original question. I hate it when the changes on me like that. So we have basically a picture. It's the parabola 25x squared, and then the line 16 or y equals 16. Now this is obviously not to scale. This actually be a very thin object. Okay. And then what it's saying, this is actually the base. This is as though you were looking down on it. And um, if you take a cross section, like right here, you're actually going to get a square. So you have to envision a third dimension. So I'll draw it. Let me see if I can
Could
draw
you
it.
could you switch the cameras,
Oh
please?
yeah,
Sorry.
yeah, my bad, my
Yeah.
bad. Um,
Thank you.
I always forget. Yeah.
Yeah, no problem.
So I'm going to draw the same object, but kind of with some perspective. So what's happening here is I take a cross section, and whatever the width of that cross section is also the height of the square that's erected over it. So the farther away from the origin I get, the bigger the square. You see that? So your object has
Oh,
kind of a shape like this. It's kind of like I don't know what you call that. It's kind of a wedge.
it's the trough from that other problem.
Yeah, something like that. It's actually a pretty easy problem to solve because all we need to do is figure out the cross-sectional area of each of these slices. So basically, well, it's X this way and X this way, right? So um, I'm going to be integrating. I probably want to integrate with respect to Y. That would be, well, let me think about that. I could do it either way. Um, First of all, let's get the bounds. So I need to figure out where they cross each other. So that would be set them equal to each other. So 16 equals 25x squared. So divide by 25. And then 4/5. So plus or minus 4/5 is x. So back here at negative 4/5, positive 4/5. As I look at this, I'm thinking I probably want to integrate with respect to y. Um, so if I solve for x, because x by itself, it's nice, but I need something in terms of y. I'm going to be moving from here to here. So x would be, well, x squared would be y over 25. So x would be square root y over 5. Okay. Now, the actual width of the cross section is two of these. So 2 over 5 square root y. So therefore, the area of the square is going to be this squared. So what do? You get 4/25 just y. Believe it or not, your integral is actually pretty easy. It's 4/25 y dy. And you're integrating from 0 to 16. And that's all you have to do. And then you just work it out. So obviously the setup is the big deal. You got to get it set up right. Otherwise, the math doesn't play nice. 16 squared is 256. That's 128. 128 times 4 is 512. So we should get 512 over 25. I hope. I did that kind of fast. So
Let's see. I got 32 over 25 for, and that was right for some reason. I don't know.
well, my problem might have been different. I was just taking the generic problem that you get off the main list.
Yeah.
When you click on yours, you'll discover that the some of the parameters have been slightly altered.
Huh. Okay. Yeah, your picture was way better though. I think that was what confused me at first, was just the picture they gave and then the problem they were trying to describe out of it.
Yeah,
Because they just give you a 2D.
right. You're supposed to somehow visualize the third dimension out of that. So this is like if you're looking straight down on the object, you wouldn't see the third dimension. But if you were
Yeah.
to kind of orient yourself a little like a fly, kind of off to the side, you'd be able to see the top, front, side, and all that. It's like a loaf of bread almost.
Yeah, thank you. Your picture was a lot more helpful.
Good deal. All right. Be aware that on this one, there's no revolution happening. So there's no need for any pi or squaring the radius. Be clear on that?
Right. Yep.
Yeah, watch out for those. There's some questions like with the frustum of a pyramid, things like that. He was in the same section.
Yeah. Mhm.
It actually sets up quite similar to this in that you just need to figure out some formula for the cross section that becomes your integrand. And but if they're not being revolved, so there's none of those circular cross section effects going on.
When it comes to the test, well, I guess, are we allowed to know, like, are we going to be dealing with mostly just like spheres and cylinders and washers, or are we going to have like more advanced
Again,
shapes going
the
on?
questions are chosen from the homework you've already experienced.
Okay.
So I don't think you would, well, it's not a sphere. We don't, um, yeah, you should expect a cylinder question and or I should say cylindrical shells,
Mhm.
washers, discs. Those are all fair game. And then stuff like this where it's not revolved, it's just regular cross sections.
Okay, good to know. Thank you.
Sure. Screen here. Seven six number four, a heavy rope, just a rope, 50 feet long, weighs half a pound per foot, hangs over the edge of a building 120 feet high. The 120-foot high building, it's irrelevant. It just needs to be higher than 50. You just don't want the rope to be like laying on the ground. How much work in feet pounds is in pulling the rope to the top of the building? So, all right. Let me see. So we want to pull the entire rope up. So, and the second question is half the rope. All right, so I'm going to stop the share. Give me a second here. Um, well, in terms of the work, remember it's just force times distance. So we're basically, let's let X be the distance. So yeah, let's just kind of reason this out. 1 foot of rope would be 1 pound, or I'm sorry, half a pound. 2 feet of rope would be 1 pound. So on and so forth. So it's basically zero point 0.5 times the length of the rope is the pounds, and then the distance. We're just adding from 0 to 50. I'm just kind of reasoning this out in my head. Um, yeah. All right. That's all it is. Yeah. So what does that give you? 1/4 x squared, and then 50 and 0. Let me see what number that is. So 2,500 divided by 4. Yep, that works. It's 25. You guys see that okay? To pull up half the rope, you just kind of make a couple of adjustments. You treat it as two problems. You're treating it as the top half is getting pulled over the edge. So 0 to 25, it should be the same. Let's go ahead and work this one out. So 1/4 x to the squared, 25 and 0. And 25 squared, 625 over 4. But then you have to add on to that basically the dead weight. That's the bottom half because that's not getting pulled over the top. And I don't think you need to integrate that. Um, you can. I mean, I'm just kind of thinking this out in my head. I don't think you need to integrate it. So 25 feet of rope, that's 12.5 pounds of rope, right? And how high are you pulling it? You're only pulling it up 25 feet, right? Yeah. Yeah, you don't need to integrate this. This is just dead weight. This is just straight up distance times force. So 25 times 12.5, 312.5. And if you sum these, you get 4. 68.75 foot-pounds. So I'm going to say no integral necessary for the second one. Did that help? Who asked this?
Yeah, it was me.
Does that help?
Yeah, there was little to no explanation in the get help. It just kind of threw equations at you and
Oh,
assumed that you.
yeah, they do that, don't they?
Yeah,
Um, yeah, take the get help for what it is. It's one of the things I've noticed about Infinity is that a lot of times the solutions or the get helps will have extra steps in them without explanation. And a lot of times those steps are cosmetic, what I mean by that is that they do something to the problem that doesn't really change the problem, it just makes it look different. And sometimes students get a little concerned because they think, what am I doing wrong? And I've seen this happen. I've actually addressed it a couple of times in ed discussions that, well, you're not doing anything wrong. It's just that they might have multiplied by 2 or cleared fractions just because it was easier arithmetically, but they didn't tell you that. So it can be a little frustrating.
yeah.
So
I've noticed
hang in
that a
there.
lot where they'll combine steps.
Yes.
They'll combine 3 or 4 different steps from, algebra or and just not tell you what they're doing. And things just disappear.
Well, and they're probably the people who write those are probably taking it for granted that, well, they know what they're doing. You should follow. Um,
I
so
took algebra 30 years ago.
yeah, I would take it with a grain of salt. Don't assume that it's perfect and that you're doing it wrong. If you have an honest question, like you just can't see the difference what you're doing and what they're doing, put it on ed discussions. I'll be glad to address it there. Um, Otherwise, you know, you might get the right answer or you might be on the right track, but you're being misled by the solution that they're showing you, and you think you're doing it wrong when in fact you're probably not doing it wrong at all. There's a lot of variation when you're working these things out. A lot of it just boils down to cosmetic. How's it look?
Okay. That helps.
Steven says, is it possible? Is it still 10 multiple choice and 6 workout problems? No, it's going to be a mix. I'll just say that, but it's going to be, again, it's questions chosen from your homework. I do want you guys to do that chapter 7 study review or whatever it's called on Infinity, because you will get some points for that. I'll roll them in with the test score, and that's got some good conceptual stuff there that you should know for the test. All right. Well, we're at the very end. Is there any last questions? Well, guys, I'm gonna go ahead and power down. I'll get this thing up on the video available probably about a half hour or so. The test is going to start on Friday morning at 12:01 a.m. So you actually get 2 full days to do it. It's the same protocol as the first test. Um, it probably won't be a big deal, but if you're one of those people that likes to wait till the very last moment, just be aware of the time difference between where you are and where in Arizona, because we did not change when the rest of the country did its change with the clocks. All right. So wherever you are, just make sure that you know the time difference between your location and Phoenix, for that matter. All righty.
All right.
Y'all have a good
Right.
couple days. And again, any questions between now and then, please put them on ed discussions. I'll look at them there.
Sounds good.
All righty. Well,
All right.
y'all have a good couple days. I'm going to end 5, 4, 3,
Thank
Thank
you.
you.
1.